Now we are going to discuss a new topic of discussion. The topic of discussion which we are going to study today is nothing but CTEs, also known as common table expressions. Now, what are those common table expressions? Why do we use common table expressions? And how do they are different from what we have studied so far? Now, remember that we stored the data in the form of views. Now, what were views? Views were virtual tables. They were storing queries for us. Do you remember that we wrote something called as subqueries, where we were writing a query within a query, which was there. And just like a combination of both of them, but very different from both of them, we have something called as common table expressions. Now, what are those common table expressions? Now, common table expressions will create tables for us, not one, but multiple tables. But those tables are created on the fly. Now, what is the meaning of on the fly table? Till the time the query is running, this table is there, existing, and once the query ends, the table has no existence. So here nothing is being stored, no memory has been captured, no storage element is captured with them, and they can simplify the logic by cleaning the code and representing it in a better form. That's what a common table expression is. Let's try to see what all common table expression tasks which we can do, how common table expressions can work, and how they can simplify our code logic with terms of writing codes, and how they can be a substitute of subqueries at certain instances. So if I share my screen, can you see that on screen I have written a definition for CTE, common table expression. Now common table expressions or CTEs are temporary run process. Now what is the meaning of temporary? That they will be running or executing till the time you are executing the query. Once the query execution is done, the logic of this table which has been created has also been vanished over there from the databases. Nothing has been stored. Now you will say that views were also not storing anything. Views were at least storing the query which was executed n number of times. The query was being stored here. The query, not even the table, and no information is being stored. Everything is created on the fly. Means everything is created when the approach is running, when the code logic is running, and when the query is in execution. So it can help me to write the complex queries in a very simplified manner, which a subquery can complicate with me, and subqueries can complicate the tasks related to the certain operations. That's when CTEs can be useful for us. Now, CTEs, also popularly known as with clause. Now, you all must be knowing that whenever I want to fetch some data, we always start the statement with respect to select. But it's not the case at all instances. Certain of the time, your querying or retrieval of the data can also start with. The common table expression has a use case of with clause. So many a times in interviews it is asked, do you know or do you have understanding related to with clause? That is nothing but they are asking you, are you sure or are you familiar with the concept known as common table expressions? So common table expressions or CTE is a temporary name result set in SQL query, which means it's a temporary name given to the result set which I wanted to use for further queries which are there. That allows you to simplify the complex queries, making them easier to read and understand as well as maintain. Now, CTs are commonly used in working with multiple subqueries. So, it can be used as a substitute for multiple subqueries which you can use. You might recognize them when they are created with a distinctive feature of with keyword. Now, how to know that it's a common table expression or CTE? It starts with a with clause instead of starting directly with select. So that is a distinctive feature which will help you to identify that this is a common table expression being written. And many a times they are definitely asked as with clause. Now, they are also used with select, insert, update, and delete statements. So it's not like they're only used within select statements. You can also write them in insert, update, as well as delete statements over here. Now, the syntax for CTE is as follows. You have to start your query or retrieval with the help of select. Not. You have to start your query retrieval with the help of with clause instead of starting it with the help of select. Now, CTE name, as you can see in the syntax which I have written over here, you will start with. As you are starting with, it will understand that you are creating what? A common table expression. and the name of this common table expression. What name you want this query to be stored. Now, many a times you can give the outcome, that what outcome do you want this query to be storing, or you can directly write the queries. So column 1, column 2, column 3 and so on, and as. This name will be stored as and the query which you want to store into your CTE. That is a common table expression which is there. If you want to create multiple common tables, you can definitely go further, but only creating common table expression is not the case. You have to write a select statements to use them, to utilize them and show some result set of those common table expressions. So here comes the main query which will be executed, which can take help of the CTE which we have created it so far. So this is how a common table expressions or with clause statements are being created. We'll see with a practical example, but before that, let's try to understand that what are the various advantages of creating a CTE. So if I see the advantages of creating CTE, it helps me to simplify complex queries, which means when my subquery can complicate a logic. I know that many people are very confused upon using subqueries because subqueries looks like something which is very complicated and something which is not understandable. It is not readability, or the readability of the data is too low with subqueries at certain instances. But if you want to simplify that, you can use something called as CTE to simplify the logic of subqueries and the complex queries which are giving you the outcome of the result set. Provides readability to understand. As I said, subqueries or certain times views can provide less readability of the data, but CTs can provide a clean readability of the data or a clear readability of the data. Replacement of a view. Definitely when I create a view will be storing a query. So every time I execute the view or the call the view, the query which is being stored into my database server will be executed n number of times. But here nothing is being stored. No storage has been captured over here. Everything is created on the fly. So instead of storing the data in the form of view, or instead of storing the query in the form of view, when you know that the query needs to be created on the fly, you can use something called as CTE. They are recursive in nature, which means a CTE can be used within and can create certain logics for the same. So this is what a CTE advantages are. Let's try to see certain examples with the same, but let's first help you to understand that how a CTE would be created with the syntax which was there, and let us solve some questions which I have brought related to the CTE. Now, I have data related to employees, if you must be knowing. So select star from employee details. I have data related to the same. Now, what I wanted to do is, I wanted only the data related to Mumbai as a location, and then I want to perform certain tasks. So, I want, let's say first I'll write the query every time and then I'll create a CTE from the same. So, select star from what? From employee details, which is there, and I want where the location is equals to Mumbai. So I will get only this data which is there. So what I wanted is, I wanted the result of this query to be stored within a CTE. So how will I do it? I have to write with clause before that, with, let's say, Mumbai city. I write the CTE name as Mumbai city, and I'll write as, which is there, and I'll store this query. So the query which is being stored, so the result of this query, that is select star from employee details where location is Mumbai, is what is stored in a name known as Mumbai city. Now it's not a view created, it's just a CTE, only on the fly approach. So when you can see, it's incomplete. It is expecting me to write something over here. So what I write, select star from. Now instead of writing employees where location is Mumbai, I will write something called as Mumbai city, which I have created it. So when I execute this, you can see it will show me data related to the Mumbai city employees which are there. Now, if I wanted to filter out the data over here, let's say where I wanted to find their salaries greater than 50,000. So which employees from Mumbai have salaries greater than 50,000 is this. Now, if I wanted to find which employees from Mumbai have their salaries greater than the average salary of the Mumbai employees. So what I can do is I can write a subquery here, select average of what? Of salary from. Instead of writing that entire table, I will write what? Mumbai city. So which employees from Mumbai city have salaries greater than the average salary? You can see this many employees are there which are having salaries greater than the average salary from the Mumbai based employees. So this logic looks complicated. Let me break it down. Let me first solve the same logic with a subquery for you, and then let me help you to understand that how CTEs were better for us. Now what we did, let me write step by step approach. What I did, step 1. Step 1, I created employees from Mumbai location table. So employees from Mumbai location table was created. Why? Because I wanted that set of records to be used. Then I filtered out the data with respect to their salaries. So I wanted average salary of what? Mumbai based employees. I wanted average salaries of the Mumbai based employees, and then I wanted to find the employees who are having greater than the average salaries of Mumbai based employees. So salaries greater than average salary of Mumbai based employees. So this was my step 2, that I wanted this, and this was my step 3. If you remember that this is what was required. So this is what I have done. Let me first write this query with the help of subquery, and then let me help you to understand how my with clause can simplify the same. So first of all, I had what? I had employee details table. So select star from employee details, which was there, and I wanted the data related to only Mumbai based employees. So where I wanted city, or let's say location is equals to Mumbai. I wanted this data. So I have used this data over here. So I wanted only those employees to be shown. So the table which I am using, as you all must be knowing that in a subquery, I'm using it in from. So you have to write it in parenthesis. So select star from what? Select star from employee details where location is equals to Mumbai, and I'll write an alias as Mumbai city. So my table name is what? Mumbai city over here. Now I wanted to find out average, where average, I wanted to find out what? Salaries of an employees which are greater than the average salary of the Mumbai based employees. So if I wanted to find out that, it will give me select average of what? Salary from. Now let's say if I write Mumbai city over here, it will give me an error. What is an error? Emmaticus.Mumbai city is not found. Why? Because Mumbai city I gave the name of the query over here. it was not a table created into my databases. So Mumbai city doesn't exist. So what I wanted to do is, if I wanted the average of this data, I need to write this query again. So I need to write this query again as Mumbai city over here, and when I run this, it is giving me the result set over here. Don't you think so? It's too complicated for me. So when I find the average salary of the employee over here, just a second. Yeah. When I find the average salary of the employee over here, just a second. Yes, this. When I find the average salary of the employee, let me write it down and outside. When I find the average salary of the employee in Mumbai location is 59,396. So the salaries which are greater than this salaries would be executed over here. So in order to find out the simplest approach, can you see I have to write a lot of logic, a lot of subquery, and the query which I wrote earlier, I had to write it again and again to write down my code to get my answer for the same. So how I can simplify this same with the help of with clause. So I will write what with, and then I'll write the name as Mumbai city over here, and I'll write the name as. And with respect to this, I'll write select star from employee details where location is equals to Mumbai. So what is this doing? It is creating what? A common table for me. The table name is Mumbai city, which will have this. So till the time this query is not ended, there is a Mumbai table created on the fly. So whatever I wanted to do, I can do it by the Mumbai city table which is there. I don't have to write the query again and again of creating a table, which I did in a subquery. So what I will do is, I'll write the main query, that is select star from Mumbai city. So I'll see only those employees from the Mumbai city. Now Mumbai city as a table is what? Is my temporary table. So this is a table which it was there. Now I know the average salary of the employees belonging to Mumbai city is what? Is 59,000 something. So it should be greater than that value. That's what I wanted. So I'll write where salary should be greater than, and you remember that in this code, same thing I did, where select average salary from, and I wrote the query again. I would not be needed to write the query again. I can write the name which I have stored the data in the with clause. So it is Mumbai city. So select average salary from. Instead of writing the query again, which I did in subquery, I can write directly as Mumbai city. Because there is an on-the-fly temporary query storing happening within the Mumbai city name. So till the time this query is not ended, Mumbai city as a table or the result set is being named, and you can use it n number of times. So here you can see you got the data with the same. The subquery also resulted the same. The with clause also resulted the same. But this helped me to simplify my logic. Instead of writing the query n number of times, I wrote the query only once and stored it with a name, a temporary name known as Mumbai city. Now, one thing to remember, nothing from this query has been stored into my database server. Not even the Mumbai city name, not even the query, not even the result set, nothing. It was on the fly created for me. So it becomes very easy for me to write down the logics for the same. Now, you can create multiple CTEs as well, that is multiple stored queries as well. So instead of writing Mumbai city, you could have created something called as average salary. So I'll write comma and I'll create one more CTE known as average salary. And in this average salary, I can store as. You can see select average salary as AVG salary from. From which table? From the Mumbai city table, which was there. So I could have created it. So instead of writing a subquery over here, I could have written directly average salary as a column which I stored. So instead of writing a subquery, what I can do is I can more simplify this logic by creating one more CTE over here. So how to create one more CTE? Just you have to write a comma over here and then write, let's say I create another CTE known as average salary as, and I write the column over here, that is select average salary, average of salary from Mumbai city as a table. So I'm using that table over here and I'll write the alias over here known as average salary. Average salary. And I can say from average salary as a thing, I am getting a column or the outcome known as average salary. I can mention that which columns are being used in the outcome just besides my name of the CTE. So this is what I have provided it. Now, instead of using it like this, I can remove the subquery. So select star from Mumbai city where, or I can use join the table known as average salary. And I can say on, I will give them name as Mumbai. And I can give this name as average salary. And I can say Mumbai dot salary is greater than a dot my average salary, which is there, and this is also giving me the outcome for the same. So this is how I can create multiple CTEs over here with respect to the with clause which was there. So I hope you understood the same. Now let's try to see and solve some questions related to the CTEs and how CTEs will help me to solve the logic for the same. Now find employees with above average salary. First of all, what I wanted to do is I wanted to store the average of the salary of the employees, and then I have to use that in order to find out which employees are having salaries greater than the average salary. So let us see. Let us find the average salary first. So I'll write select average of salaries from what? From employee details. So what is an overall average salary which you can see over here? It's 61,460 over here. So whichever employees are having salaries greater than 64,460, I want those employees details over here. So instead of using a subquery, I am storing this logic into what? With. So I will write with and I'll give a name known as average salary. And I can write that this is going to return me as salary over here. So I will write salary over here with respect to as. So a CT is being created. So what it is showing me in the outcome, if I don't write this, anyhow it is going to show me all the columns which my CT is going to return. If I write a specific column, only that column output will be shown. So what I want select star from employee details where I can say where my salary is greater than the average salary. If I write like this, you can see it is not showing me anything. So what I can do is I can write join average salary over here, which we did earlier, and then average salary dot sal. So this many employees are having salaries greater than the average salaries it is showing. Now I don't want all the columns from my this table. Can you see salary as a column is also shown in the outcome? I want only the columns which are there in employee details. So I can modify employee details dot star. So only those columns are being shown which are available into my employee details and not all of them. So this is how I can simplify my logic with respect to finding the average employees who are having salaries above the average salary with the help of CTE. Now one thing to remember, nothing from this is being stored over here into my database servers. If you can see, no views are being created, no stored procedures, no functions, nothing will be stored, not even in the employee tables, nothing is being created and stored. So this is what how we can solve the first question over here. Now let's see the next question. Can you see that find out the top 3 highest salaries which are there. So find 3 highest salaries or the highest salaries of the employee. Now if I see select star from employee details which is there, if I see this data, can you see the data over here? How will I know that which employees are the top 3 or the 3 highest paying employees? What I can do is order by which was there, and I can say order by with respect to salaries. So it will order the data with respect to salaries in descending order. Yes. And I can then limit 3, which could be possibly there. So limit 3. I want 3 highest paying employees which are there into my organization. I can store this query into CT and get the answer. But let me write it with the help of Windows functions. Now you all must be familiar with what a window function is. Window function will run for each record and it will throw outcome for each row. So let me use something called as ranking. So rank on the basis of salaries which are there. So I'll write over, rank over, and I'll write order by salaries. In which order do I want? I want it in descending order, which was there as salary rank. I give this data over here and this is giving me the ranking over here. So first, second, third, fourth, fifth and so on. So this is the data which is being provided. I want this to be stored into my CTE. So can I store a window function into CTE? The answer is yes. So how will I store it? I'll create, let's say I'll create another with clause. So with highest salary. So I'm creating a table named as highest salary as, and I'll store this as my CTE, a common table expression over here. And how I can simplify this logic over here is just I need to mention select star from highest salary where. Now I can use the columns which I had created into my CTE as it is. So where the salary rank is less than or equals to 3, that is the first, second and third. So here you can see the 3 highest paying employees salaries are being shown on the basis of the ranking. If someone says that 5, so I can definitely see the 5 ranking salaries which are there. So 5 highest paid employees or top 5 highest salaries consisting employees, I can find it over here with the help of the CTE which is there. So this is how I have found it out over here. Now, what is the next question? The next question is find employees who earn more than their department's average salary. If you remember the same question which we have solved in my subquery. So how my subquery was using, I used a correlated subquery over here in order to find out which employees was having salaries greater than the department's average salary which was there. So how did I do it? You remember that I did select star from employee details which was there, and I used this as my outer query. So I wrote it as outer over here, if you remember. So outer query, or let's say I write it as O, which was there, and then what we did, where salary, and we used a correlated subquery over here. Salary is greater than the, and we wrote what, select average salary from employee details. Again, I used employee details over here as E. So here I was using where E dot department names is equals to O dot department name. So I wanted to check the departments which were there, and I wanted department wise average salary. So group by what? I was grouping the data on the basis of department. So you might be remembering that this is what we have seen. So on the basis of the department average salary we did. Now it was a correlated subquery. You remember that correlated subquery was running for each row of the outer query for the inner query. So we had 50 records. So inner query was executing 50 number of times. So this can be computationally heavy at certain instances, because the number of records you have in the outer query, the inner query is going to execute that number of records over here. And there is a correlation maintained. So can I simplify the same logic with the help of a with statement? Let's see. So I write with, and let's say department stats. I create something called as department stats as a table, and I write as. And in this, I'll write select department. I want to create groups of departments, so I'll write department, comma, I'll write total number of employees. Let's see. Count star as total employees. Now you can write your query separately and see how it executes, and then directly implement it with a with clause. I'm writing it over here. So average of salary as average salary over here. From which table I'm taking? From employee details table. And I want to group the data on the basis of what? Departments, which was there. So this is what I have created in my CTE, and if I do select star from department stats, so it shows me the query of this table which is being stored over here. That is the total number of employees in each department and the average salary for each department. I wanted to find that which employees are having greater than the average salaries over here. So from department stats, let's say I do join over here with respect to employees. So if you can see that I'm using and joining the employee detail table over here, and I'll write on, where I can take, I'll name it as departments as D and as E, which is there. So on, I can use E dot salary, which should be greater than D dot the department salary, which I wrote it as average salary. So if you can see, this is being shown over here related to the employee details, at which employees are having the same. Now here, as you can see, I am returning all the data from both the tables, the department stats as well as the employee details. I don't want from department stats, so E dot star, which was there. So it is returning all the employees who are earning greater or more than their department's average salary over here. So this is how the data is being shown. This is how the result is being calculated for the same query. I showed you with an approach of a subquery as well as a CTE, which could be used. Now, as I said, now CTEs are not only possible to be useful or used when you have something called as select statements. You can definitely use it into your insert, update, delete kind of approaches as well. So I will be showing you one approach related to using CTEs into your update statements. Now we have to give 10% raise to all the employees who have experience over 5 years. Now, first of all, let me see how many employees do they have experience over 5 years. So if I do select star from employee details, so it will show me all the details of the employees which are there. Now, I wanted to know that which employees are having experiences greater than 5 years. So I'll write where experience is greater than 5 years. So greater than 5 years. So how many employees are having experience greater than 5 years? 3 employees are having experience greater than 5 years. Or if I write greater than equals to, let's see how many employees are there. There are 5 employees who are having experiences greater than 5 years or equals to 5 years, which are there. So I wanted to update their salaries, which was there. So let me store it into a with clause over here. So with long term employees. So I'll create a name as long term employees and I store this query with the name as long term. And instead of writing select statement, what I'm writing in the main query, I'm writing an update statement over here. So what I'm writing, update. Now what I wanted to update, I wanted to update employee details as a table. Now what I wanted to do, I wanted to set their salary, which is raised by 10%. So salary, base salary plus salary is 10% into 0.10. So we have done that over here. Not for all the employees. If I don't write a where condition, it is going to do it for all the employees. I wanted to do only for those employees who are having experience greater than 5 years. So I'll write where over here and I will check for experiences which is there. So experience, let's say I write experience which is there, should be within. Obviously, this is giving me multiple values, so I'm writing in. What? Select employee ID from which table? From the long-term experience table. So long-term employee table, which is there. So I write like this and you can see it has updated. Let us see select star from employee details where the experience of the employee is greater than 5 years. Greater than or equals to 5 years. So here you can see the salaries are being showing over here. So what it is actually doing is it is taking those employee IDs from the long-term employees who are having experience greater than 5 years and then it is updating their salary from whatever the salary was with respect to the 10% raise which has happened and it is showing me the data over here. So here if I execute this, you can see this is the data which we have related to the same. So 0 rows match. Let me write here as employee ID. There is no match which is found. Employee ID, employee name, which was there. Let's say the department of the employees and let's say the salary of the employees. So this is the data which it is having. So 0 rows selected Y. So experience, yeah, not for the experience. Experience is not matching. So I want the employee IDs to match over here. So employee ID in. And when I do, here you can see 5 rows have changed. So when I see the employees who are having experiences greater than 5 years, you can see their salaries have shown a hike of what, 10% over here. So the raise of 10% have been added. Earlier I added experience, and that's why the value was not matching and no update was seen over here. So ID should match from the long term employees table. So this is how we saw that we can use a CTE into my update as well. So this was all about CTE, common table expressions, where your query was not stored, the data was not, a table was not created. On the fly, the tables were created, the query result sets were named, and you can use those query result set names into your query, into your single select statements or update statements or your delete statements to update the logics and run the queries according to the convenience which is there. So this is how CTEs or common table expression could be used to simplify the logic for certain type of operations related to the data. So I hope we are clear with CTE.